Hello everyone, so a very good morning to all of you. So in the previous class I have solved a numerical related to the bond shear and development length, right? So let's solve another interesting numerical which is very much important for your semester. Okay, so this is very much important, so let's start. So here it is said that a rectangular beam of size 230 mm width, so the size is given, that means if you consider this is a cross section of a beam, the width is 230 meter, that means the value of B, this one is 230 mm and the effective depth is 450. So that means if you consider these are the reinforcement, so this D, the D value is 450 mm, okay, and it is B. So it is reinforced with 4 numbers of bar of 20 mm diameter. So that means here in spite of 3 we are having 4 numbers of bar and all are having the diameter of 20 mm dia, okay. So we are having 4 number 20 mm dia bar, okay. So what we need to determine is the vertical shear reinforcement. So we need to determine the vertical shear reinforcement to resist the factor shear force, that is for first case 1 that is 70 kilonewton and for case 2 it is 250 kilonewton. So we are considering the first case. So first case, the factored shear force for the first case is 70 kilonewton, rather you can say the VU, that means the factored shear force, okay. So the value of VU that is given for the first case, it is 70 kilonewton. So you already know that to determine the tau V, that means the nominal shear stress, definitely we will see the code. To determine the nominal shear stress, the formula is VU by BD, right, where VU is the factored shear force and the value that this particular equation we will see in the IS 456 2000. So let's go there. Yes. So here you can see, as per clause number 40.1, the value of the nominal shear stress is tau V is equals to VU by BD, okay. So from here I can determine the value of the tau V, that means the nominal shear stress, where VU is the shear force due to the design loads, which is in our case that is 70 kilonewton, okay. Now the B value, that means the breadth value of the beam section, we have the value of beam section that is 230 mm, okay, and the D value, that means the effective depth, that is most probably 450. So we know all the values, so we can put the value over here and we can determine the value of tau V. So let's see what is the value of tau V. The VU is 70 kilonewton, so I am multiplying it with 1000 to get the value in Newton per millimeter square, and B into D, B is 230 into 450. So what is the value? The value you get, that is 0.67 Newton per millimeter square. 0.67 Newton per millimeter square. Okay, so it should be it is tau v, right? So definitely it should be less than the tau c max. Now from where I get the value of tau c max? Let's check this condition over in IS code. So yes, here in table 20 you can see the maximum shear stress value, that is the tau c max. Okay, so in our case, what is the grade of the concrete? Definitely it is depends on the grade of concrete. For M15, M20, M25 we have different values, right? So let's see. In our case the grade of concrete is not given, right? So we consider the grade of concrete is M20 and the grade of steel, that is Fe415. Okay, so if it is not given in the question, you can consider this one. So look, I am considering M20. So for M20, what is the maximum value? That means the tau c max value. Let's see in the code. So for M20 the value is 2.8. okay, 2.8. so definitely it is less than, sorry, yes, so definitely this 0.67 Newton per millimeter square is less than 2.8 Newton per millimeter square. That means it is okay, right? Now I need to check that what is the value of the tau c, that means the design shear stress. So let's see. So to determine the tau c, we need to see the table 19 in IS 456 2000. Okay, just above this table 20 you can see the table 19. So in table 19 we need to determine the value of the tau c. Okay, tau c means the design shear strength of concrete, that is in Newton per millimeter square. But to determine the tau c, we need to choose two particular things. One is the grade of the concrete, in our case it is M20, and another thing is the percentage of steel, that is AS by BD into 100. Okay, so let's determine the percentage of steel. So I am just determining over here in whiteboard. So first we determine the AST value. Okay, look here, the AST can be calculated by 4 number into 20 mm dia, right? So for 20 mm dia, what is the cross sectional area? That is pi by 4 into 20 square, and here we have 4 numbers of bars, so multiply it with the 4. So the value that you get 1257 mm square. Okay, this is the area of steel which is required. Now we need to determine the percentage of steel. So to determine the percentage of steel, you know the formula, that is AST by BD into 100. So in place of AST you can put 1257, and B is nothing but the width of the beam, that is 230, and the effective depth is 450. So multiply it with 100. So the percentage of steel that you get, that is 1.21. Okay, 1.21 percentage. Let's cross check. I have already calculated it. So 1257 divided by 230 divided by 450 into 100. Yes, so this is correct. So 1.214 something, so I am considering 1.21%. okay, so now I have two values to determine the tau c. First one is the percentage of steel and the grade of concrete. So now I can determine, right? So let's see the code. Yes, so our percentage of steel that we get, that is 1.21%, right? And the grade of concrete is M20. So I need to consider this particular column. So 1.21, it is near to this 1.25, right? So definitely the value will be in between 0.62 and 0.67, right? So you can determine the exact value of 1.21 percentage, but so if you need to determine the exact value, you need to make the interpolation, right? So let's determine by using the interpolation. In the previous problem we are directly put the value. Now I will show you to how to make the interpolation. Okay, so we have just write two values of the corresponding to percentage of steel value. Okay, so for 1 it is 0.62, for 1.25 it is 0.67. Look, the percentage of steel, and here it is tau c. So the percentage of steel value is 1.00 and 1.25, and the tau c value, that is 0.62, which is corresponding value of 1% of steel, and similarly here it is 0.67 for 1.25. Now we need to determine the value of 1.21. So what we can do is we can make the interpolation over here and can determine the value. How? Look, what is the gap between these two values and what is the gap between these two values? We can use the unitary method and just put the value of 1.21. How? Look, here the difference is in percentage of steel, that is 0.25. So for this much differences in percentage of steel, here what will be the difference? That is 0.67 minus 0.62. So I am considering the unitary method. So for this much differences in percentage of steel, here the difference is 0.67 minus 0.62. So for 1, what will be the value? That is 0.67 minus 0.62 by 0.25. And for the difference of 1.21 minus 1.0, what will be the difference for this particular case? Very simple, we just need to multiply with the 1.21 minus 1.0. Okay, so when you solve this equation, you will get the value of 0.042. You just cross check. Look, 0.67 minus 0.62 by 0.25 into 0.21. Look, 0.042. So this is the corresponding value of difference of 0.21, right? Here 1.21 minus 1.00 means 0.21. So we need to determine the value of 1.21. So for 1, we know the corresponding value, that is 0.62, and for 0.21 difference that we got, that is 0.042. So we just need to add those two values. Okay, so for 1.21 the corresponding value will be 0.62, which is the corresponding value of the percentage of steel of 1.00 percentage, and plus this value that we get, that is for the difference of 0.21, right? So 0.042. Okay, so in this way you can determine the interpolation. So the value that we get, that is 0.662. Okay, that is the ultimate tau c value, which is corresponding value of 1.21 percentage. So yeah, and the unit is Newton per millimeter square. So yes, in this way you can determine the corresponding value of 1.21 percentage of steel that we get. It is 0.662. okay, that is in Newton per millimeter square. So now we can put the value over here. So just remove this. So tau c that we get, that is 0.662 Newton per millimeter square. Now I need to check that whether the tau v is greater than tau c or less than tau c. So in this case the tau v value is 0.67 and the tau c value is 0.662. That means it is greater than tau c. So shear reinforcement should be provided. So shear reinforcement provided, right? So if the shear reinforcement is provided, so I need to see the code and use the equation and can determine the how much shear reinforcement is provided, right? Look, now we have determined the tau c value, right, from the table 19, and we also know the tau v. Now the question is whether the shear reinforcement is needed or not. That particular thing we need to see, right? So what is the condition that the shear reinforcement is needed or not? That is tau v greater than tau c, whether this condition satisfied or not. Okay, so this particular thing is given in the code, that is in, you can see here, that is 40.4. when the tau v exceeds tau c given in table 19, shear reinforcement shall be provided any of the following forms. So there are 3 forms are there. So any of the following forms we need to provide the shear reinforcement. That means if this condition satisfied, that means tau v is greater than tau c, then we need to provide the shear reinforcement. Okay, so that means in our case this condition satisfied. So what is the next step? The next step is we need to determine the balance shear force. Okay, so we need to determine the balance shear force, which is given by VUS equals to VU minus tau c BD. So where VU is the balance shear force. Why we need to determine this? Because we need to determine the shear reinforcement. So for that shear reinforcement we need this particular value. So that is given also in the code. Let's see. Here you can see the shear reinforcement shall be provided to carry a shear equal to this shear equal to, that means this is the balance shear, okay, and that is equals to VU minus tau c BD. So VU is equals to VU minus tau c BD. Okay, so that is given here. So we know all the values, that means the value of VU we already know, tau c is already determined, and B and D value also known. So that is why if we put the value we can get the VUS, and that particular VUS we will put in this particular formula. Okay, and then we will get this SV. Okay, so let's see what is the value of VUS first. Okay, so let's determine what is the value of VUS. So VUS equals to VU. What is the value of VU? That is given 70 kilonewton. So 70, we should multiply it with 1000 to get the value in Newton. Tau c value that we have just determined from table 19, that is 0.662, and P into D, what is the value of B? B is 230 and D is 450. So 230 into 450, the ultimate value that we get in Newton, right? So what will be the value? That is 1.48 into 10 to the power 3 Newton. Rather you can say 1.48 kilonewton. Okay, so the value of U is, that means the balance shear force that we have determined. Now what we need to do is, so first I am removing this part. So now we will put this equation as I have told earlier, that is VUS is equal to 0.87 FY ASB D by SB. Okay, so let's write the formula, that is VUS equals to 0.87 FY ASB into D by SB. SB is the spacing and VUS is the balance shear force. So in this equation we know the value of VUS, that means the balance shear force, that is known. Fy value is also known. ASV, so ASV, that means we need to consider here, in previous problem we have considered 2 leg stirrup at 10 mm die, right? Here we will consider the same thing, that means 2 leg stirrup and having 10 mm dia. So what will be the value of ASB? So ASB will be 2 into, as it is 2 leg stirrup, and the cross sectional area of 10 mm dia bar is 5 by 4 into 10 square. Okay, so this is the value of ASB. You can determine the value, you can just put the value over here, and the value of D is also known, that is 450 mm, right? ASB we need to calculate. So apart from this SB value, we know all the values, right? So let's determine the value of SB. So SB will be 0.87 into Fy is 415. ASB that is 2 leg stirrup, that is 2 into 5 by 4 into 10 square, and into D is 450 and divided by VUS. The VUS that we have determined, that is 1.48 or 1.48 into 10 to the power 3, because all the other values in Newton per millimeter square. So I am converted this value from kilonewton to Newton. Okay, so when you determine the value of SB, let's see what is the value. It will be 0.87 into 415 into 2 into 78.5, because 5 by 4 into 10 square is 78.5, that means the cross sectional area of the 10 mm dia bar. So 78.5 into the effective depth, that is 450, right? So 450 now divided by 1.48 into 10 to the power 3, that means 1480. Okay, so 1480, 17,235 millimeter. So this is the spacing as per our calculation. The value of the spacing is this much. This is too much higher, but yeah, in the code it is given that what is the maximum value of the spacing that we can provide. So as per the code, the maximum value, 1 second, as per the code, the maximum spacing that we can provide is V max, that is 0.75 D or less than equals to 300 mm. So if you put the value of D over here, what is the value of D? That is 450. So 0.75 into 450, let's see what is the value. That is 337. So 337.5 mm. So definitely it is greater than 300. So we will not consider this particular value. We will consider this 300 because this particular value that we get, this is too much higher. So we are considering the summary, that is the shear reinforcement summary. that we are going to provide, that is 2 leg stirrup of 10 mm dia, right? 10 mm dia at the rate 300 mm center to center. So this is the solution that we got for. Okay, similarly the same thing needs to be done for 250 kilonewton. Just in place of 70 kilonewton we need to consider the 250 kilonewton. Okay, so you just try, and in the next class we will solve that. Okay, thank you.